Good morning. Let's start today's lesson with good things. What's your good thing to share with us today? For me, it's that I was able to avoid any problems with the weather last night by staying at a friend's house. Fortunately, there was no bad weather, but today is forecasted to be some really bad weather in this area, and let's pray that something bad doesn't happen. All right, so let's talk about the second sample of spud potato chips that we collected, quote unquote, and the following results that were obtained. And this time, the sample mean, this X bar, is 28.32, and the true population mean is 28.3. So we're looking at almost precisely the same. The sample's average is exactly the same as the population average. However, I want you to look closer at the graph. What do you notice about the distribution of this new sample compared to the original sample that we took of the Spuds potato chips? Do you see what's going on here? You've got very closely knitted stuff, and then this one's really spread out. You notice the mean of the sample is very close to the true population mean here, but the data values are very spread out. One bag has only 22 grams of chips, while another bag has 34. So this is a very much larger range in this sample. The sample of chips has an example of high variability and no statistical bias. The situation can be a big problem for the manufacturer. People who get bags of only 22 grams of chips probably don't really care what the average of the chips are. They just care that they were shorted about what? 6 grams of chips. Okay, compare the standard deviations that were given for the original distribution on page 1 and this distribution. And you're going to see the second set is almost twice that of the first set. This tells us the data set has high variability. And here you can see the standard deviation 2.84, and this is 1.46. It's almost double. What are your recommendations to the manufacturer? If I were the quality assurance guy, I'd say check the machinery and see if the weight of the chips can be regulated a little more accurately. So we're going to identify the following sample data sets as high or low statistical bias and high or low variability. So we want to look at here, I want to look at this graphical display, and we can see from the sample, just by looking at it, where the mean is. It's probably kind of close to the mode. You see that? And same here, probably right around here. But the population mean is at a different spot. As you can see here, this one, they're a little more spread out, but you can see that the mean's probably right around here. Same thing here. So if the population mean is in a different spot than the sample mean, that's called high bias. If the population mean and the sample mean are about in the same spot, that's low statistical bias. If the data values are really close together, that's low variability. And if they're really spread out, that's called high variability. So we can see this first one, A, is probably high bias and low variability. The second one, probably high variability and high bias. Yeah, and I was right. See, population mean is far away from the sample mean, and the values are really spread out. Now, you can tell this is the values that are really spread out. That's variability. The measure of spread out, and the more spread out it is, the higher the variability. The less spread out it is, the lower the variability. The further away the population mean is from the sample mean, the higher the statistical bias, and the closer the population mean is to the sample mean, the lower the statistical bias. So that means that this is low statistical bias because the population mean and the sample mean are in the same spot, but it's really spread out data values, so that's high variability. Finally, the last one is exactly what any quality assurance guy likes to see: low statistical bias and low variability. So variability can be caused by natural variability or induced variability. Natural variability occurs with no human intervention or error. For example, temperatures vary from hour to hour, day to day, and location to location. Strength varies from person to person, and grades on a given test vary from person to person. There's nothing we can do about that. Some people are gifted, some people are not with strength or intelligence. And the temperatures really varies. If you're in a higher longitude or higher latitude than most people, your weather is going to be colder than people with lower latitudes. There's nothing you can do about that. When the sun goes down, the temperature goes down. When the sun comes up, the temperature goes up. It's the same as it goes, okay? Depending on a weather pattern when it comes in, that can change things too. Now, induced variability is a little different. And induced variability is outside forces that act to change the variability that naturally occur. People affect the environment. We all know this. Can result in causing temperatures to vary more, less, or differently than before. People work out or eat differently, which affects their strength, and test grades are influenced by new instructional techniques or changing study patterns. So I'm going to leave you with this launch. I'll let you read it. Mark Wahlberg's one of my favorite guys to do memes, and this is pretty funny if you know about statistics. That kind of helps you out. The statistics of social media. That's kind of funny if you think about it. Anyway, let me let you go. There is an assignment attached to this in the Google Classroom. Be sure to get that done. In the meantime, be blessed. Be a blessing.